Good day, my name is Shivani Apra, and today my group and I will be discussing the building and launching of a miniature trebuchet. We were tasked with this for our course DYNA 1001, where we are to introduce this application for children aged 3 to 5 years old and older, if need be, so as to introduce them to the physics at an early age, such as mechanical leverage, projectile motions, and gravity. During this project, my group and I delved into the mathematical modeling of systems so as to be able to calculate the distances needed for us to be able to achieve using counterweights. The breakdown of these mathematical equations are done by my next group member, Kurila.
Hello, good day. My name is Cody Lala, and today I'll be describing the process in which we derived our equations for our model of the trebuchet. Rotational dynamics as well as projectile motion was used when modeling our trebuchet. When modeling our trebuchet, we first looked at the total torque produced by the trebuchet itself. To find this, we first look at the torque produced by the projectile and minused it from the torque produced by the counterweight. We then looked at the total moments of inertia, and the total moments of inertia was found by adding the moments of inertia of the projectile and the moments of inertia of the counterweight. To find the moments of inertia of the projectile, we use the moments of inertia equation for a sphere, as that resembles that of the shape used for our projectile. To find the moments of inertia of the counterweight, we use the moments of inertia equation for a cylinder, as that resembles the shape used for our counterweight. We then found the angular acceleration of the projectile, which was found by dividing the total torque produced by the total moments of inertia. After finding the angular acceleration, we then found the angular velocity, which was found by finding the square root of 2 multiplied by the angular acceleration multiplied by the angle swept by the arm when launching the projectile. We then found the velocity of the projectile by multiplying the angular velocity by the distance of the projectile from the fulcrum or the pivot of the trebuchet. We then found the distance traveled by the projectile by using the projectile motion equation for distance traveled.
Good day, my name is Shivanan Sakram, and today I'll be talking about the components of the trebuchet. Our first component would be the counterweight. A heavy mass at the short end of the beam, usually consisting of materials like rocks or sand. It provides the necessary force when dropped to swing the arm and launch a projectile. The counterweight used in our project was washers, as well as nuts of varying sizes and weight. Next, we have the sling, a flexible attachment at the end of the long arm that holds the projectile. Its design allows it to release the projectile at the optimal moment for maximum distance. The material used in our project was a polymer string. Next, we would have the A-frame, a sturdy structure that holds the entire mechanism. It's usually robust to withstand forces of launching without toppling or breaking. The material used in our project was wood. Next, we would have the beam or launch arm, the main lever arm of the trebuchet divided into a long and short segment by the pivot or axle. The longer end holds the string and the projectile, while the shorter end is attached to the counterweight. Then we have the axle or fulcrum or pivot, around which the beam rotates. It is centrally located on the frame. The material used for our axle was a threaded bolt cut to specific lengths to our necessary needs. Next, we'll have the baseboard or the base. This part supports the frame on the ground. It is usually wide to provide stability during operation of the trebuchet. Next, we will have the trebuchet sling pouch, often referred to simply as pouch. It is a crucial component of trebuchet functionality. The sling pouch holds the projectile securely during the launch process. And finally, we will have the release mechanism. The release mechanism is usually a simple pin or hook that the sling cord slips off or pulls away from the peak of the swing. The timing of this release is crucial. If the release occurs too early or too late, it can drastically affect the distance and accuracy of the projectile. The optimal release point is generally when the arm reaches a near vertical position, allowing the projectile to be thrown forward with maximum leverage or velocity.
Now we have a demonstration of the trebuchet in action.
Details on the experimental method used included going to the UTC campus, Point Lisas, where we laid tape onto the ground and using a measuring tape, we marked off the various points on the tape, and a table at the beginning of the tape a little ways off was set up where we rested our trebuchet upon. Before launching, we determined randomly a distance we wanted to achieve, inputted it into our mathematical modeling calculation, and got the necessary counterweight in respect. Launching was then done, and distances were then verified. Lastly, we have some tables that we obtained during the building and testing of our project. Upon experimenting with theoretical values, it was found that the distance achieved was off by 0.1 meters. So this may be due to friction, air resistance, and dynamic behaviors during launching that could be vibration, oscillation, and nonlinearities. So this may not be fully captured when doing a theoretical model. And lastly, the difference in the counterweight's mass distribution, release mechanism, and positioning can also impact the energy transfer to the projectile. With all these contributing factors, this is why the distance achieved was slightly different. In conclusion, and as seen in the video of testing the device, it was an overall success. Through extensive research and development with our group, we were able to successfully design, build, and test the trebuchet with minimal errors. Though it was a bit difficult and mishaps were encountered, it will be an experience we all will never forget, as this gave us a small insight into the field of engineering. I do hope you enjoyed our video, and thank you for watching.